Hello and welcome to a new video. My name is Herwig Juster and today we have arrived in the last part of our electric design properties series. We will bring today the material requirements together with the different polymers and components in electric vehicles. And this in turn can be useful for you as a decision help during material selection. Okay, let us get started. So first, in the previous parts we discussed the different requirements which the all-singing, all-dancing plastic compound needs to fulfill nowadays. So we discussed CTI values, insulation, isolation, frame retardancy and also EMI shielding. But as you can see here, there are many more other requirements which need to be considered, like such as the thermal shock resistance, the color, overmolding capability for bus bars. For the connectors we need lead-free reflow soldering and so on. So the first thing we discuss is the other material requirements versus the polymeric materials. So I've selected here the CTI, the EMI shielding, temperature resistance, chemical resistance, flammability, so mainly the UL 94 V0 rating at different thickness and processing. And starting here with the commodities, polypropylene, ultra high molecular weight polyethylene and cross-linked polyolefin. So those three fulfill all the CTI criteria. However, with EMI shielding there is a modification needed if that is needed. Temperature resistance, so here we have to be careful. Minus 40 degrees is feasible, however in the upper limit it's more 80, maximum 100 for a short period. Chemical resistance is really good with polyolefins, and flammability as a neat resin, it will not fulfill the UL 94 V0, however with flame retardants you can achieve this level. Processing really good. Then we have the big section of engineering polymers. I've here selected a PPT, short chain aliphatic polyamide, long chain aliphatic polyamide, polycarbonate and PPA. CTI also never a problem. EMI shielding, here modification is needed. Temperature resistant is good in this range, so it can go up to 100 and above. Chemical resistance is okay, and also flammability needs modification, except the polycarbonate, they have usually inherent V0. Processing is also good. And then on the high performance polymer range, selected a PPS, a PPA peak, LCP and polyethamide and polymer PVDF. Here we have also overall a good fulfillment of the material requirements, just missing the EMI shielding, the modification, and for example with polymers like PPS and LCP we need to be careful with the CTI value. And on the processing side, high performance polymer, due to the high melting temperatures and high mold temperatures, are more challenging in processing, in molding and in extrusion. Although this is a first start, you can insert many more material requirements and cross-check them with the different polymers. Then when we continue now with the material requirement versus the components, so I've listed here on the left the different applications, so battery pack, battery housing, charging systems, high voltage connectors, mechanic components which needs to be sealed, thermal management, power electronics. And again our requirements, material requirements from EMI shielding, flame retardancy, chemical, dimensional stability and so on. When you look for example high voltage connectors, here we need EMI shielding, we need to have flame retardancy, we need to have a good dimension stability, low shrinkage warpage, to have precise replication of the connectors to fit everything and seal everything. And this is also linked to the next point, the creep resistance, and also color stability, because here we need to apply, when it's high voltage, it's above 60 volts, it needs to be colored in orange. And also the dielectric strength and electrical insulation values. And this is also thought as a guideline for you to get a feeling what are the different material requirements versus the components, and then you can also compare it with the previous slide we discussed before. Okay, and now I've selected what we already previously discussed, high voltage components versus the operating temperature versus the polymeric material. And so when you look here on the upper side, we have standard applications, connector standard. Then we have already higher voltage range, 400 volt and above, so, and ultra high and extreme. This is really 800 volt, 1000, 2000 volts. Here we have the operating temperatures, so this range 80 to 105, yeah, polyolefins, polypropylene, and also then up to 125 engineering polymers, polycarbonate, aliphatic polyamides, polyesters. Then above that we come already in the semi-aromatic polyamides and also the PS66 PPA blends. And when you reach then the 160, 70, 80, then we have PPS, LCP, polysulfones and PGAS as polymers. Also to mention here the polyamide imide and also PBI. Okay, if you want to have more information on polymer engineering topics, I highly recommend you my blog findoutaboutplastics.com, as well as on material selection, my online courses. I will link you both the blog and the online courses in the description below. Okay, I would like to thank you for watching, and do not forget to subscribe and smash that like button. Till next time, bye!